Our solar system is a familiar place. One star, the Sun, with everything else in orbit. But what if Jupiter was not a planet but a star? Imagine a tiny, cool red dwarf, about 90 times more massive than Jupiter, sharing our solar system. This new star, Nemesis, would change everything. Planetary orbits, the warmth on Earth, even our night sky. Instead of a simple system, we'd have a complex gravitational dance between two suns. The story of our solar system's formation would be rewritten. The original gas cloud would split, forming two stars, our Sun and Nemesis, a faint cherry-red companion. Planets would form in a chaotic disk, shaped by the gravity of both stars. The rules for where life could exist would be completely different. Let's journey into this alternate solar system. We'll explore how planets move, feel the faint warmth of a red dwarf, and gaze at a sky with two suns. Could Earth still be habitable? Could life exist in such a dynamic system? By imagining this reality, we learn about the delicate balance that makes our own existence possible. This is a story of gravity, light, and the wild diversity of worlds the universe can create. Welcome to a solar system with two stars. To understand this new solar system, we go back 4.6 billion years. Instead of one dense core forming the Sun, the nebula fragments into two. One becomes our Sun, the other, Nemesis. Nemesis gathers enough mass, 90 times more than Jupiter, to ignite as a red dwarf. Now two stars are born from the same cosmic cradle. Their combined gravity stirs the protoplanetary disk, making planet formation chaotic. The Sun dominates the inner disk. Nemesis shapes the outer regions. Between them, gravity battles for control, changing where planets can form. The classic frost line is replaced by a complex thermal map, warm near the Sun, cold in between, and another warm zone near Nemesis. This reshapes the ingredients for planet formation, creating a lineup of worlds unlike anything we know. The solar system's architecture is fundamentally altered. Planets, moons, and asteroids all find new places in this cosmic tug-of-war. The stage is set for a solar system of surprises. Two stars, one extraordinary beginning. With two stars, planetary orbits become a complex dance. Earth would still orbit the Sun, but Nemesis's gravity would constantly tug at it, introducing subtle wobbles. Over millennia, these tugs could destabilize orbits, making Earth's path less predictable. Inner planets would experience similar chaos, their paths shifting over time. Outer planets like Saturn and Uranus would feel Nemesis's pull even more, possibly orbiting the system's center of mass instead of just the Sun. Some worlds might even be captured by Nemesis, becoming planets of a red dwarf within our own solar system. Stable and unstable regions would emerge. Resonant orbits could offer safe havens, while others would be dangerously chaotic. Planets or asteroids straying into unstable zones could be ejected or flung into new orbits. The solar system would be a place of both new stability and new chaos. The elegant order we know would be replaced by a dynamic, ever-changing system. Every planet's journey would be shaped by the gravitational tug-of-war between two suns. The result? A solar system in constant motion with new rules for survival. Welcome to the binary dance. Nemesis, our red dwarf, would be a faint but steady source of heat and light. Its surface is much cooler than the Sun's, radiating mostly in infrared. From Earth, Nemesis would be a distant, dim companion, its warmth barely noticeable, but always present. The Sun gives Earth over 1,300 watts per square meter. Nemesis, less than 0.04. Not enough to change our climate, but a subtle, persistent addition to Earth's energy. For outer worlds, Nemesis's warmth would be transformative. Moons like Titan could thaw, their frozen surfaces warmed by the red dwarf's glow. The outer solar system would shift from deep freeze to a region of gentle warmth. Light would change too. Nemesis's red glow would bathe nights on Earth in a faint crimson, and on distant moons, it would dominate the sky. The Sun would be a bright point. Nemesis, a large, dull red disk. Every world would experience a new visual and thermal environment. The presence of two suns would redefine day, night, and the very nature of light. The solar system would never look or feel the same. The habitable zone, the region where liquid water can exist, would be redefined. With Nemesis, the Sun's habitable zone shifts outward. Mars might now be warm enough for water. Nemesis would have its own tight habitable zone close to the red dwarf. Moons or planets orbiting Nemesis could thaw, developing oceans and atmospheres. These worlds would be tidally locked, with one side always facing Nemesis, creating unique climates. But life here would face challenges: unstable orbits, extreme climate swings, and powerful stellar flares from the red dwarf. Survival would require strong magnetic fields and thick atmospheres. The dual star system offers more places for life, but also more dangers. Habitability becomes a moving target, shaped by the interplay of two stars. The search for life would expand to new, unexpected worlds. In this system, the possibilities and the risks multiply. Picture a night on this alternate Earth. The sky glows with familiar stars, and a new ruby-red disk, Nemesis. Brighter than Venus, dimmer than the moon, Nemesis casts a soft crimson glow, never setting with the sun. Sometimes it hangs in twilight, sometimes it rises late at night, painting the world in eerie red. True darkness vanishes, even moonless nights shimmer with Nemesis's light. Shadows stretch long and strange, and oceans reflect a bloody hue. Now travel to a moon of Uranus. The sun is a distant star, but Nemesis dominates the sky, a huge red orb casting perpetual twilight. The landscape is bathed in monochrome, everything tinted deep red. From the Kuiper belt, the two suns are a mismatched pair. The sun, a white-hot diamond. Nemesis, a cherry-red jewel. They circle each other over centuries, ruling a system of planets caught in their gravitational embrace. Every view is a reminder. This is a binary system, not a solitary one. The sky tells the story of two stars, forever linked. The universe feels bigger, stranger, and more alive. Our place in it, more mysterious than ever. Nemesis's gravity would be a cosmic sculptor, reshaping the belts of small objects. The asteroid belt, once herded by Jupiter, would be devastated. Nemesis's pull would eject most asteroids, leaving a vast emptiness. Inner planets would face intense bombardment. As asteroids are flung inward, others would be tossed out of the system. The Kuiper belt's stability would vanish, its icy bodies scattered or captured by Nemesis. A chaotic swarm of comets and dwarf planets would orbit the red dwarf, while others rain into the inner solar system. The Oort cloud, loosely bound to the sun, would be torn apart. Trillions of comets sent careening or lost to interstellar space. The solar system would become far more dangerous, with impacts a constant threat. The belts we know would be erased, replaced by chaos and risk. The presence of a second sun would forever change the architecture of our cosmic neighborhood. Survival here would mean adapting to a world in flux. Jupiter's moons, Io, Europa, Ganymede, and Callisto, would become planets of Nemesis. Some might be ejected, but others would settle into new orbits, forming a compact planetary system around the red dwarf. Europa, now deep in Nemesis's habitable zone, could melt into a global ocean, a prime candidate for life. Life here would be different, tidally locked, with one side in eternal day, the other in night. The twilight ring could be a haven for life, shielded from Nemesis's flares by deep oceans. Io would become even more volcanic, a true hellscape. Ganymede might develop a thick atmosphere, becoming a supersized titan. The old Jovian system would be reborn, diverse, compact, and full of new worlds to explore. A miniature solar system within our own, shaped by the light of a red dwarf. The possibilities for life and discovery would multiply. The transformation would be nothing short of cosmic alchemy. Comparing our real solar system to this binary version reveals how special our home is. Our single sun brings order and stability, allowing life to flourish. With two stars, orbits become unpredictable, impacts more frequent, and chaos the norm. Yet, new habitable zones and water worlds could emerge, expanding the possibilities for life. Binary systems show us that the universe is full of surprises. Life might thrive in places we never imagined. The architecture of a planetary system shapes everything: stability, danger, and opportunity. Imagining a red dwarf companion helps us appreciate the delicate balance that makes Earth a haven. Our existence is the result of a fortunate cosmic arrangement. By exploring alternate realities, we deepen our understanding of what makes a world habitable, and we gain a greater appreciation for the remarkable, stable system we call home.